Welcome and hello. This is a video exercise in MODSIM, and what we're going to be doing in this exercise is working with Watch Logic Calculator. This is where you can define the demand of a node based off the flow through other links in the same network, as well as using the functions either min-max, log, natural log, exponential, or squared, and a linear weighting coefficient that you can multiply by that term. All right, so let's go ahead and get started. What I have on the screen here is my MODSIM 8.6 brand new instance. So let's start sketching out a network. I'm going to start with a non-storage node right here, which is going to provide me some inflow. I'll just call it RS500. And then after that, I'm going to add a number of consumptive demands. So I'll just start adding them right here. How about 4? And then after that, a network sync to terminate the network. I'm going to label these, how about D1 for demand 1, and I'm going to move the label over here to the side, D2, D3, D4. All right. I'm just going to, move the label over to the side. Oops. Okay, so I'm going to make the connection in the order that I sketched. So there's that, and then D1 to D2, D2 to D3, and finally D4 to the sync. All right, so that looks good. I'm going to go File and then Save just before I forget. Right here is the project directory. I'm going to just call this exercise 2. Next, what I want to do is define the properties of these different objects, these different elements. So for the inflow, I'll start there by doing a double click. This is the inflow demand. So what I'm defining here is the inflow. With units of acre feet per month, I'm going to just say we have a constant 10,000 acre feet per month entering the network at this node. So that's true all year long. And that's all I have to do for my RS50 non-storage node. I'll click apply and then OK. Now let's go ahead and add demands and priorities to our demand nodes here, our consumptive demand nodes D1 through D4. So right click on D1 here to open up the properties box. I'm going to be using a time series to define the inflow. That's the default setting here for demand definition type is time series. We'll just leave the priority at 100. That's the default, and that's fine. We're going to use the same priority for all 4 of our demands. And then if I click on the time series tab, on my clipboard, I already have copied the time series I want to use here. So I'm going to go right click and then paste column of data. And you can see how each month of the year, we increase the flow from 1,000 up to 4,000, and then it just holds steady at 4,000. So we can click the plot just to see what that looks like. This is the line image or line version, and then here's the bar version. So I'll click apply and then click OK. Now I need to define the properties for the other demands. So I'm going to go right click and properties. This is D2 now. I'm going to click on the general tab here. And for the demand node type, I'm going to say it's still consumptive. However, for the demand definition type, I'm going to switch time series to watch links. This opens up the watch links tab and now gives me the ability to take into account the flow rate of different links in the network as a way to define the demand at this node D2. At the top of page 108 in the user's manual, we have this equation here. This D here is the demand at that consumptive node. And then it's basically going to be the sum of these 6 terms here. I will leave a link to the lesson where I describe this in more detail, but this is what we're doing. So the link will be in the description of this video if you have trouble finding it. It's in the lessons playlist. All right, so what I'm going to do here is I'm going to call this scenario 1, where demands D2, D3, and D4 here can use up half of the water in the river at their location. So for D2, that means I'm going to set the watch link will be D1, D2. That's the amount of flow that arrives at D2. And then for transference type, I'm going to set this to either max or min. Doesn't really matter because it's only going to be that value. I'm not going to have multiple links. And then I said half. So for maximum, I'm going to set the factor up here to 0.5. Okay. So that's all I need to do for demand D2. I'm going to basically reproduce that exact same watch links data for D3 and D4, except I'm going to shift the watch link to view the link that enters that particular demand node. Okay, so click apply, click OK. I'm going to show you what that means here. So for D3, I'm going to right click, open up the properties dialog box, click on general, and then switch the demand type to watch links. Okay, the watch links tab has been activated. For maximum, I'm going to set this to 0.5. And then for the links it's going to watch, it's going to be D2 to D3. So let's make that selection there. And then transference type will be maximum, which is right there. Apply and OK. All right, the last one is D4. So right click, properties. Let's set the watch links as the type. So general tab and then watch links. Okay, I'm in the watch links now. And then as before, 0.5. And then now for the link we want to watch, it's going to be D3 to D4 right there. Transference type needs to be set to maximum and apply and OK. All right, so let's just save the network and then think about what we expect to have happen. We have a constant 10,000 acre feet per month entering D1. Its demand ranges from 1,000 up to 4,000. So then we're going to see flows to D2 from 9,000 to 6,000. And then from there, we're going to see the flow half, half, and half until it arrives at the sink. So let's run the model and then see if that's what we get. So I'm going to click the play button here. Yes, I'm ready to run MODSIM. Okay, so that ran. To view the data, I'm going to go to the MODSIM menu and then click on graphing mode. This means whenever I click on a specific element like a link or a node, it's going to bring up the data plot here. Now, if I move this off to the side and then click on the next one, it kind of gets in the way. So to minimize it is the solution. Then click all the links. So that was D1, D2. Here's D2, D3. Here's D3, D4, and then finally D4 to the sink. Oops, did I get that one? There we go. I'm going to reopen up that dialog box. And now you can see here on the left, we have the 5 different links, which all have series data associated with it. To sort of declutter the plot, let's go ahead and unselect the data in some of those series. So we're starting with 10,000 acre feet. That's the only link selected here, RS 500 to D1, this one right here. Now D1, D2, that will have a flow of 9,000 and then it decreases down to 6,000 because remember, the demand at D1 is 4,000 at its peak, which is the case for like the last 5 months of the year. D2, D3 is basically going to take half of this flow. So that means the first month it'll take 4,500, resulting in a D2, D3 of 4,500. And then at the end, it's seeing 6,000 acre feet per month, which means it's going to demand 3,000 acre feet per month, leaving 3,000 acre feet per month. All right, that's my guess. And boom, here it is 4,500, stair stepping down to 3,000. That's the flow in D2, D3. I'm just going to go ahead and click on the other two. This is D3, D4, similar shape, and then D4 to the sink. Again, you can see how the value is halving of the flow in the river for each of these reaches between the demand nodes. Another way to look at this data is let's look at the nodes. So I'm going to click on the D1 node, and here is the demand that we put in. We already saw this, but we didn't actually explicitly see the demand that was calculated for the other 3 demand nodes. So I'm going to minimize this as before, and then just click on D2, D3, and D4. That data was added to the plot here, and boom, here it is. All right, I'm going to, again, toggle off these other series. We saw this one. The demand at D2, this is going to equal half of the flow arriving at D2. So that's going to start at 4,500 and then stair step down to 3,000 because towards the end of the year, towards the end of the simulation, there's only 6,000 acre feet per month arriving at D2. D3 has a similar shape where it starts at 2,300 and then the demand drops down to about 1,500. And then D4, here's the demand there, starts at about 1,200, drops down to close to 800. We can get the actual numbers, but I just wanted to take a look at the shape. All right, so that was scenario 1. I'm going to run through a couple more scenarios just so we kind of get the hang of how these watch links demands work. For the second scenario, I'm going to set the demand at node D2 to a time series, just like D1. However, it's going to have a different shape where it starts at 4,000 acre foot per month, drops down to 1,000. So let's go ahead and go right click on D2 consumptive demand node. Here's the properties box. I'm going to click on general and then switch watch links over to time series. Okay. So we no longer have a watch links tab. We have this time series tab. And then I've copied onto my clipboard the data I want to paste. So paste columns. It's going to start at 4,000 and then drop down to 1,000. So here is what the plot looks like in the line version. And then here is the bar version. It's kind of the opposite of what we were looking at for the D1 demand. So here is the D1 demand where it starts at 1,000 and then it stair steps up to 4,000. Okay, so let's go ahead and with that being the only change for scenario 2 versus scenario 1, I'm going to save the model and then come up to the MODSIM menu, click on Run MODSIM. Okay. Again, let's go ahead and take a look at the results. This time I'm going to look at the demand nodes first. So go up to MODSIM. Okay, I have graphing mode toggled on. That's good. So I'm going to click on D1. This shouldn't be too surprising. In fact, let me minimize that again. D2, D3, and D4. Okay, let's bring those plots up. I'm going to toggle off D4 and D3. Here are the demands at nodes D1 and D2. So D1 is rising up to 4,000. D2 starts at 4,000 and drops down to 1,000. Now the demand at D3, remember, is half of the flow arriving at D3. We didn't change that from the first scenario run. So here is the value there. It's this line. It starts at about 2,500 because it receives 5,000, and then it drops down to what looks like 1,500 and then back up to 2,500. Okay, so that's definitely a different shape than we saw before. And the D4 demand is probably going to be just like it, but half. And sure enough, there it is down here. If we wanted to take a look at the flow through the links, we can go ahead and click on the links once again. So I'm just going to click all these. And here is the plot on the screen. We start off with 10,000 acre feet per month at the very top. And then after that, after the demand one has taken some flow, what we're seeing right here in the light orange is the flow from D1 to D2. Dark orange is from D2 to D3. Light blue is D3 to D4. And then this darker blue from D4 to the sink. All right, so for the next scenario, what I'm going to do is increase the inflow at this RS500 node. Currently, oops, this is the graphing view. I'm going to go right click properties. That's what I meant to do. Currently, we have a constant flow rate entering our network of 10,000 acre feet per month. I'm going to go ahead and change that to 20,000 acre feet per month. So all I'm going to do is double this inflow, click apply, OK, and then run the model once again to see what the changes are. This time, let's take a look at the links first. So here is our 20,000 acre feet per month. I'm going to minimize that and then just select all of here's the 20,000 entering D1. And then here is the flow entering D2. So it starts at 19,000, drops down to 16,000 because remember, it only requires 1,000 to 4,000. So there's a lot more flow. This vertical axis does not start at 0. Just notice it starts at 16,000 and goes up to 20,000. And it changes as I add and remove data sets on this left panel. All right, so the flow going from D2 to D3 is shown here. So that starts at 15,000, drops down to 13,000, and then back up to 15,000. Now keep in mind the demand at D3 has never changed, which is going to be half of this value right here. So it's a lot more than it was before. Half of 15,000 is 7,500. Half of 13,000 is 6,500. So we should basically see the same shape, but half of the magnitude down if I toggle on D3. Yeah, this vertical distance on the plot is the demand consumed by D3. And then D4 should have a similar shape just below it. Now I'm curious to see the demand because D3 is going to have a higher demand than D1 and D2. So let's check that out. Here's the demand at D1. Okay, I'm going to minimize again. D2, D3, and D4. Okay, here's the plot. Yep, as expected. We have D3 way up here. D4 has a similar shape right here. And then D1 and D2 are doing their crisscross as before. All right, well, that's it for the normal scenarios. What I want to do is I have in my notes something wild. And what I'm going to do is for demand D4, I'm going to set the demand based on the sum of the squares of the next upstream 3 links. So let's go right click on D4, properties. I'm not sure when you would use this, By the way, I should probably also point out you can customize the demand by going up to MODSIM and then custom runs. This is a code editor that I have not made a video or a lesson about yet at the time of this recording, but I plan to, and we're going to check out all the different ways we can customize the demand at a node and other things within the network. But for this exercise, let's stick with the watch links calculator. So I'm going to go right click and properties. Okay. Currently, it's set to 50% of the flow in link D3, D4, the flow entering that node. I'm going to go ahead and just set this back to 1. It's not going to be used anyway, but what I'm going to do is set the transference type to square. There it is. And I'm going to do the same thing for the other two upstream nodes, so D2, D3, which is right there. And then also I want one for D1, D2, and I want to set the transference type to square for both of these. Okay. Now the weight, this would be a huge number, and it would just crash the program because it's infeasible. But what I'm going to do here for the factor is multiply it by a very small number, specifically 1e to the negative 10. So that's a very small but positive number. And then I'll click apply and then OK. So I'm not really sure what to expect here. I prepared this, but I forgot. So let's see what happens. I'm going to run MODSIM. Let's just go ahead and take a look at this demand. Okay, something didn't work. If I click on the upstream link, okay, that looks correct. We didn't change anything there. Okay, so the link flows upstream of D4 look correct. I think one thing I need to do is come up to my MODSIM network settings and then change this 2 to a larger number, maybe a 4. I'll click apply and then OK. And then let's go ahead and run the model once again. So run, yes, save. And now let's see what we got for our graph. Okay, there we go. That's an important point, is make sure that you have a adequate number of decimal places precision in your calculations. I think the default is 0, which is integer, but yeah, that's probably something I should get better at remembering to do. All right, so what we're seeing here is kind of a wild graph. It's the demand at D4 over the course of the 12-month simulation, starting just above 1700, dropping down to around 1200, 1250, and then back up to 1450, almost 1500. I'm not going to try to explain that, but yeah, it's basically that very small leading coefficient times the sum of the squares of the 3 links upstream. So yeah, the last scenario I want to do here is demonstrate how to add multiple terms together. Here's that equation once again. Here's the demand, and we have multiple terms. So far, we've only been using one term at a time, mostly this max term, but that last example used this square term here, and this W subscript SQR was that very small number that we multiplied just so we can get an actual like normal size number. What we want to do is now do a combination of maximum and this squared term, and we're going to double up by reusing the D3, D4 link twice. So I'll show you what that looks like, and then we'll call it good. So I'm going to right click on the D4 demand node, click on properties. I'm going to leave everything here the same, but what I'm going to do is actually add a node reference down here. It's going to be D3, D4. That's correct. The transference type now isn't going to be squared. We're actually going to use this D3, D4 link as a maximum. And then just to keep the numbers looking good, I'm going to not make it equal to that maximum, but 40%, so 0.4. So whatever values that we saw for the demand at the previous scenario for D4, we're going to increase that by 40% of the inflow coming into D4. All right, so I'll click apply and OK. Again, I'm not sure when in the real world you would need that particular demand, but let's run it anyway for the sake of learning. All right, so that ran. Let's go ahead and see what our demands are now. And here is the graph. All right, now it's starting off at 4,700, dropping down to about 3,800, and then back up to about 4,500. So it looks like we added about 3,000 acre feet per month to the demand at D4 between this scenario versus the previous one where we didn't have that, add that 40% of the flow entering the D4 node. All right, well, that's all I had prepared for this lesson. We talked about watch links. We set up this network, and then we modified the demands. Some were time series demands, but other were watch length demands. We ran the simulation, and then we viewed the results.